Hello everyone, myself Nisarg Rajvilas Wasule from second year electrical engineering department. Today I am going to teach you a topic two-port network as an assignment for network analysis subject. So first of all, I am going to tell what is a port. A port is a terminal from which the current enters and leaves is called as a port. As an example, we can take a transformer from which we give the input and we acquire the output. So two-port network is a special case of multi-port network in which each port consists of two terminals, one for entry and other for exit. Input port consists of 1 and 1 dash, and output port consists of 2 and 2 dash. So in Z parameters, which are also known as impedance or open circuit parameters. In Z parameters, input and output voltage for two-port network can be expressed as V1 and V2, and current are expressed as I1 and I2. This is the equivalent circuit for two-port network for Z parameters. So from this, by applying mesh analysis, we get these conditions. By Ohm's law, we get this condition: V is equals to I into Z. So applying these conditions to a two-port network, we get V1 V2 is equals to I1 I2 into Z11 Z12 Z21 and Z22, from which we can get these equations: V1 is equals to Z11 I1 plus Z12 I2. This is our first condition, first expression, and V2 is equals to Z21 I1 plus Z22 I2. This is our second expression. Now assuming case 1, assume I2 is equals to 0, which will be V2 open circuit. So now put I2 in equation 1 and 2. We get V1 is equals to Z11 I1 plus Z12 I2. Now as I2 is equals to 0, so this entire term will be 0. So we get this Z11 I1. So now Z11 is equals to V1 upon I1. Same with expression 2, V2 is equals to Z21 I1 plus Z22 I2. So as I2 is equals to 0, this entire term will be 0. So we get V2 is equals to Z21 I1. So now Z21 is equals to V2 upon I1. So in case 2, we will be assuming I1 is equals to 0, which will be V1 is equals to open circuit. So now V1, now putting this I1 in equation 1 and 2, we will be getting values of Z. We will be getting values of Z22 and Z11. Sorry, we will be getting values of Z12 and Z22. So V1 is equals to Z11 I1 plus Z12 I2. As I1 is equals to 0, this term will be 0. So V1 is equals to Z12 I2. So now Z12 will be V1 upon I2. Same with equation 2, we will be doing Z22, we will be getting Z22 I2, as the I1 term will be 0. So now Z22 will be V2 upon I2. So as in two-port networks, there are two conditions. First is reciprocal condition, in which Z12 is equals to Z21. In the sense, V1 upon I1 is equals to V2 upon I1. And in symmetrical condition, Z11 is equals to Z22. In the sense, V1 upon I1 is equals to V2 upon I2. So we will be taking one example for the Z parameters two-port network. There is this circuit in which this is input port and this is output port. So here will be currents I1 and this is I2. So we will be applying the mesh analysis for the given circuit. So we will be assuming direction of current like this for first, and for second mesh I2 in this direction, and this will be third mesh I3. So we have taken the direction of current with respect to I1, which will be flowing like this, and I2, which will be flowing like this. So this is our first mesh, second mesh, and this is our third mesh. So for first mesh, we will be getting expression V1 is equals to 3I1 minus 2I3. This is our first expression. For second mesh, we will be getting V2 is equals to 4i2 plus 4i3. And for the third mesh, we will be getting, since here there is no voltage source, it will be 0, 8i3 plus 4i2 minus 2i1. So as in this first equation, as our generalized equation says, i1 plus i2, there should be zi1 plus zi2. So in this network we have to replace this i3 by i2, and in second we have to replace this i3 by i1. So we will be doing 8i3 for getting the value of i3, which we will be putting in these two equations. So 8i3 is equals to 2i1 minus 4i2. We have shifted this to this side. So i3 will be 0.25 i1 by dividing this to this and this to this, minus 0.5 i2. So this will be our fourth equation. So now we will be putting the equation fourth in equation first and 2. So we will be getting v1 is equals to 3i1 minus 2. Putting the value of i3 in this, it will be 0.25 i1 minus 0.5 i2, which will be 3i1. Multiplying this to this, we will be getting 0.5 i1 minus plus 1 i2. So now i1 will be 3 minus 0.5 plus i2. So it will be 2.5 i1 plus i2. This will be our fifth equation. Now putting equation fourth in equation 2. So we will be getting v2 is equals to 4i2 plus 4 0.25 i1 minus 0.5 i2. So it will be 4i2 plus 1 i1 minus 2 i2. So now i2 4 minus 2 plus i1. So we will be getting v2 is equals to 2i2 plus i1. This will be our sixth equation. Now putting these equations in the form of matrix. So we will be getting v1 v2 is equals to i1 i2. Now value of z11 will be 2.5, value of z12 will be 1, value of z21 will be also 1, and value of z22 will be 2. So as our reciprocal condition says, z12 is equals to z21. So the value of z12 is 1 and the value of z21 is also 1. So we can say v1 upon i2 is equals to v2 upon i1, and it is proved that in this example it is a reciprocal condition where z12 is equals to z21. So thank you for listening me.